Inverse functions. Let's look at some examples. All right, so first let's review a little bit. What is an inverse function? A function is an inverse function if it's one-to-one. And one of the ways to test if a function is one-to-one is to have a horizontal line test. So here we see this horizontal line, not the vertical, right? Because that's for to test if it's a function, but to test if it's an inverse function, it has to pass the horizontal line test. So this one is one-to-one, it's one-to-one, and this one is not one-to-one. And so a function is one-to-one if each x in the domain for the f, there's exactly one range. Okay, so here we have an example here, and here we have an example here where it's not. So that's just a quick review of what an inverse function is overall. So then we deal with trig functions, right? So inverse trig functions. So trigonomic functions are all periodic functions, and we know that. Thus, the graphs of none of them pass the horizontal line test, and so they're not one-to-one. This means none of them have the inverse unless the domain of each is restricted to make them one-to-one. So we can only deal with inverse functions if we restrict our domain. Since the graphs are periodic, if we pick an appropriate domain, we can use all the values of that range. So these are universal restrictions. So if we restrict the domain of f of x to negative pi over 2 to pi over 2, we have made the function one-to-one. So you can see this restriction here. So the range is from -1 to 1. Although there are many ways to restrict it, like I said, this is the agreed upon interval used. Okay, so we denote the inverse y equals sine inverse x. So it is read y is the inverse of sine x and means y is the real number angle whose sine value is x. Be careful with the notation. The superscript -1 is not an exponent. To avoid this notation, some books and some people, even on tests and quizzes, you might see the notation arcsine instead. So instead of the sine inverse, you'll see arcsine. Okay, and this is what the graph of an arcsine looks like as well. Cosine, here is the cosine function. It's restricted. So the domain of the inverse is -1 to 1, and the range is from 0 to pi. All right, so that means that the positive values yield in the first quadrant and the negative values yield in the second quadrant. And so here we have it here. Tangent, here we have the tangent is the domain of the inverse function is -infinity to +infinity. And the range is negative pi over 2 to pi over 2. So the inverse of the tangent will yield values in the first and fourth quadrant. And so the same process is used to find the inverse function of the remaining trigonomic functions, cotangent, secant, and cosecant. And here we have them here. Again, the range for sine is negative pi over 2 to pi over 2. For cosine is 0 to pi. For tangent is negative pi over 2 to pi over 2. Cotangent is 0 to pi. Secant, notice that pi over 2 is not included. And notice for cosecant, 0 is not included. So if you put those things in your calculator, because you can actually put these in your calculator, if you put them in your calculator, it will yield invalid or error message because they don't exist. All right, so let's take an example. And so remember that when you're dealing with inverse functions, that tangent only deals from quadrant 1 to quadrant 4. So from basically from pi to negative pi, right? Because from 1 to -1. So these are the only two quadrants that we can deal in when we deal with the inverse of sine. And it's still a little tricky even then. So let's look at -1/2. So when I have sine -1/2, you can see, so again, just in case, this is for me also. Cosine cosine is usually how my coordinates are labeled here. So this is my cosine, my sine, and this is really just angles of a right triangle, correct? So here, from here to here is this triangle that we're referring to here. And my triangle is not drawn correctly, but it's supposed to be a right triangle. I hope you know that. And so this is going down from here to -1, and this value goes to 2. And so we need to find out what this value is. The only thing is that this value, we know that if it's from 1 to 2, then this is has to give me an angle of 30. However, I can't rotate through these negative values to get to this value of, because it's not 30, it's down here, so it has to be -30. So I can't rotate through here to get to my 330, which we would assume that it would be equal to. So instead, I need to change this to, like I changed it here, to -30. So sine inverse of -1/2 is -30. So again, cosine needs to stay in my first and fourth quadrants. However, I cannot rotate through my other two quadrants to find out to get other answers. So because of that, then I have to say that this is -30. Okay. Okay. I can also say, because I didn't specify here, should it be in degrees or should it be in radians? So you can also say this is equal to -pi/6. Oh, the time is flying. Okay, so the next one is tan inverse of negative square root of 3. And again, tangent is very similar. Well, not similar, but it is also in the first and fourth quadrants like sine is. And so I'm looking for this ratio of -3/2, and I can use my coordinate points to help me find the ratio where it becomes -3/2. And so I know that tangent is really sine over cosine. And so sine over cosine, I want it to equal up to this -√3. And I know that if I have square root of 3 over 2 divided by 1/2, and I only know this because I do it all the time, and you will know this also because you do it all the time, that I should, when I have a value like that, then that's going to give me that √3. So when I simplify that out, I get square root of 3 divided by 2 times 2/1, which gives me √3. I need a negative though. Okay, so where can I have a negative value? Well, the negative value will be down here. However, I cannot write it out. I can't rotate all the way down over this way. So that means that I need to make my negative come here instead. So this is the value that I would use instead. And that value is at, I can't just say 60, I have to say -60. Or I can say -pi/3. All right, the next one, cosine inverse of √3/2. Okay, for cosine, I'm in quadrants 1 and I'm in quadrants 2. So I can rotate from quadrant 1 to quadrant 2. And so I'm just looking for that value where it's -3, negative square root 3/2. And here I see it right here. It's negative square root 3/2. That one was easy, right? So I get 5pi/6 or 150. So again, I didn't specify if it should be in radians or degrees. So either answer is acceptable. However, if it's an answer choice, you want to pick the answer choice that they have, the answer choices that they have. All right, the next one, cosecant. Remember we talked about cosecant. Again, it is from 1 to 4, but 0 is left out. So I need it to be at 2 root 2. And let me write that down. So it's from 0. Sorry, no, it's not. It's from negative pi over 2 to 0 and union with 0 to pi over 2. I'll make sure I wrote that correctly. Yes. And I already said this. So this is included. So it should be a bracket instead. But the 0 is not included. All right. So then cosecant is really, and there's some people that use the triangles, and I just use the trig function rule. So cosecant is really 1 over sine, correct? And so I need to find out where, if I invert my sine, I get 2 root 3. So again, I'm looking at the positive 1 and 4. And so the one that has sine where the root 3 is in the sine coordinate is here. So that means that is equal to 60 degrees or is equal to pi over 3. All right, let's look at the next one. Evaluate cosine inverse of negative 1 over root 2. And so again, cosine is in 1 and 2. So from 0 to pi, I'm running out of time, but I still want you all to see how I'm getting these numbers. So from 0 to pi, yep, so from 1 to 2. Those are the coordinates that I can use. And so I need a negative, and so this is, again, I'm just used to looking at these numbers, so I know I'm looking for root 2, and so 1 over root 2, and it's actually negative, is equivalent to negative root 2 over 2. So I need a negative root 2 over 2. It's not in quadrant 1, it's definitely in quadrant 2. So I get 3 pi over 4 or 135. All right, I hope I didn't go too fast. Did I do this one? No, I didn't. I didn't do this one because the other one was negative. This time it's positive. And again, remember, tangent is sine over cosine. And I need it to be root 3, so I know that it has to be, it's the same thing that we got the last time. Pi over 3, except it is positive this time. Pi over 3 and 60. Remember, this is the same answer. Pi over 3 is equal to 60, okay? All right, let's mix it up a little bit, okay? So we know how to find these values. So let's see what we can do. So now if we have cosine of 0, so we want to find on our unit circle where we have the cosine of 0. Cosine 0 is pi over 2. So I'm sorry, excuse me, I was mixing myself up. Cosine 0 is here, so 0, what is the cosine value? It's 1. And so now I just need to find the cosecant value at 1. And cosecant is just basically the inverse of sine, so cosecant, it would be at 0 degrees. Do I have time for that? All right, so the secant of 0 is 1 because it's just inverse of cosine. And then the sine inverse of 1 would give me pi over 2. and I hope that this helps.